Uses of radioactivity. Tracers. Now, these are used to track the flow of a substance through a system, and they've got many applications in science, and medical uses is one of them. The patient consumes a tiny amount of radioactive isotope, which then emits gamma radiation. Now, alpha and beta radiation are not suitable because they would not be able to escape the body. A detection machine is then used to pick up the path of the tracer, and this can show blockages and other things in the body. An example is technetium-99m. Now, this is used extensively in nuclear diagnosis, and one thing it's used for is in detecting coronary artery disease. It's very suitable for this use because it has a half-life of only 6 hours. So the patient is not exposed to radiation for an extended time. And it emits gamma rays of sufficient energy to escape the body, so you can actually detect it. Thickness monitoring, for example, when factories are making metal foil. Now, the foil is pressed into thin layers by rollers, and beta particles will pass through, but only through a certain thickness. And if the foil gets thicker, then the stream of particles is not detected on the other side. And then the rollers automatically receive a message to increase the pressure again. So this shows the diagram, the thin metal foil in the middle there, that orange line in the middle, being pressed flat by the rollers. So why use beta radiation for this? Well, alpha radiation isn't used because it can't pass through foil anyway, so that would be useless. And gamma radiation isn't used because it passes through most things, so that would be useless. Radioactive dating is also sometimes known as carbon dating. Now, this is used to find the age of ancient objects. Any organic material, by which I mean any material that was once living, for example fossils, contain carbon-14. We've already come across this. It's a radioactive isotope of carbon. And this is present naturally in the atmosphere in tiny amounts, as in 1 part per trillion. Now, the half-life of carbon-14 is 5,730 years, and it decays into nitrogen-14 through beta decay. Now, the amount of carbon-14 present in the material can tell us its approximate age, since we can estimate the amount present when the material was originally formed. So, for example, if we assume that the original atmosphere contained 1 part per trillion, as it does now when we're looking at a piece of plant material, then we can assume that plants also contained carbon-14 in the same proportion because they take in carbon during photosynthesis. So if a piece of plant material had a count rate of 1/32 of a living piece of equal mass, so if you do the maths that works out to 5 half-lives, then this is 5 half-lives of decay. So therefore the relic must be approximately 28,650 years old, or 5 times the half-life.